Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation. Okay, let's get started. It's wonderful to be with you today. I really love this talk. I spent so much time working on it and trying to understand the intricacies of artificial intelligence. As you may know, I already have an artificial intelligence talk on my website, but this one is much newer and it covers a lot of the new information about generative AI and RAG and so forth. If you're curious about these slides or any of the other presentation on my website, you can see my URL right there and a QR code underneath it. And that's where you basically see these slides and 62 other presentations if you're interested. We do have 86 slides here. So I am going to be skipping or going quickly through certain sections. As I mentioned before, I do have another AI talk called Postgres and the Artificial Intelligence Landscape. Again, URL there at the bottom. If you do download these slides, anything in blue can be clicked on, and therefore you would go right to that slide deck or to the website or whatever supplementary information I've shown here. But what are we going to talk about today? We're going to talk about the AI explosion, the huge amount of new information, new details, and interest in AI that is surprisingly new. Surprisingly, this whole AI sort of excitement is only in the past 18-20 months. So we're going to talk about that. Then we're going to get into just a lot of complexity. I am going to go kind of quickly through that. We're going to talk about hyperdimensional vectors, which is fundamental to AI. We're going to talk about how training happens, again, fundamental to particularly generative AI. We're going to then get more practical. We're talking about semantic and vector search. We'll talk about transformers, which is sort of the internal part of generative AI. And then we're going to talk about retrieval-augmented generation. There's a lot of database use there. And then finally, deployment options. This is where I'm going to focus most of the time because there is a large component where databases can help. And I think this will be probably the most interesting to the audience. But again, you have to understand how AI works to understand where databases can help. If you just kind of launch in and try and use databases without understanding how they work, you can't really make the best use of the database. Where does it fit? Where does it not fit? I have some details about that. I think those will be particularly helpful. So the AI explosion, November 30, 2022, big date. I know it doesn't really register as a big date for you right now, but historically we may look at that as a big date looking back. The big interesting part was the release of ChatGPT 4. And it's basically the ability to have human-like conversations and human-like output, particularly at that point, text-like output from AI. And this was just foundational and really set the AI world in storm. And we're still really living in the ramifications of that date and that release. If you're interested about generative AI, I do have a URL right here at the bottom. It's basically a 6-part, probably 5-hour YouTube series about generative AI. Feel free to look at that. But to really define where we are today, we have to talk about the two types of AI. And up until I would say that ChatGPT 4, the general understanding of AI in the public was one that was discriminative or predictive. So things like classification, fraudulent credit card, that's a classic, image recognition, recommendations for websites, predictive trends, and even language translation were pretty much the bread and butter of AI before ChatGPT 4 became popular. But generative AI came in and really changed the public's perception of what was possible, particularly ChatGPT 4, which was for text, and DAL-E, which I'm not going to talk about too much today, which is for images and allowed for the creation of AI image content as well. Generative AI use cases, we're still trying to understand what all of those use cases are, but things like chatbots, semantic search, which I'll talk about, summarization, language translation, of course, image creation, that's one of the creation of text, creation of images. And there are some software aspects, particularly code creation, code analysis. I've used that a couple times. Even programming language conversion, I've been pretty impressed with what is possible there. So you might want to look at, again, some of the URLs there at the bottom to get more details. Comparing the two, discriminative again before ChatGPT 4, really focusing on domain specific problems and supervised learning. And it usually outputs some kind of prediction or recommendation, whereas generative AI requires much more training, but is much more of a general solution. And it outputs new content, which has really shocked a lot of people. Again, the concept of generative here is significant. For discriminative, you're doing the training, trying to basically create boundaries between various outputs or various probabilities of output. Whereas with generative AI, you're effectively creating these vectors in very high dimensional spaces, which I'll talk about in the next section. And those vectors are actually used to generate unique content. Really creative use of AI, I think. So hyperdimensional math, again, I said we are going to talk about some complex stuff. We are going to be talking about some higher dimensional math because that is fundamental to generative AI. Mathematics is very good at representing things that aren't possible in the real three-dimensional world. For example, thousands of dimensions, numbers of atoms that are far exceeding, numbers that are far exceed the number of atoms in the universe, for example. Calculus, another example of representing infinite values or infinite processes. Again, really interesting. But there is a concept called duality, which effectively you can look at things in different representations, physical, computer, or even abstract. And that's where mathematics comes in. Now, most dimensionality vectors in generative AI use typically between 1,000 and 12,000 dimensions. Now, we live in a three-dimensional world, so it's kind of hard to understand what that looks like. But what I have here is an image of a 10-dimensional graph. And again, if this is 10 dimensions, imagine what 1,000 looks like. The range of values in that much of a dimensionality space is so vast that we really have trouble as humans, I think, conceptually understanding what that looks like. And basically, that's all I wanted to talk about in terms of dimensionality. Then I want to talk about the training aspect. Again, generative AI requires a huge amount of training. That you basically create. I'm just going to go through a very simple example where you take every word in the English alphabet. Let's suppose that's 50,000 words, and you basically create a vector randomly for every one of those words. So imagine 1,000 dimensional space or 12,000 dimensional space. You just randomly create these vectors. Now, 50,000 vectors in 1,000 dimensional space, they have there's nothing near these vectors. They're just kind of floating there with no vectors near them at all because 1,000 dimensional space is just huge. So what happens after that is that you take a huge amount of documents and you basically adjust these vectors in these 1,000-dimensional spaces to make them closer or farther away from other words. Now, that might sound kind of like a non-useful thing to do, but what happens is you can make small adjustments to represent relationships between words, and that's typically how generative AI actually generates its output. Again, a lot of URLs here at the bottom, a lot of detail. But let's look at a simple example. I took the words king and queen, man and woman. This is the traditional 4-word example that most generative AI uses, and I randomly placed them in this 2-dimensional graph. Again, not 1,000 dimensions. But what I do is I take some statements like the king is a tall man, and I basically move each word closer to the other words in the sentence. So king moves closer to tall, king moves closer to man, and so forth. So you basically take the thing you break them up into words and you move them mathematically because king is normally appearing with the word man or tall or whatever. Queen is normally appearing with woman. Beautiful is normally appearing with woman or queen. And castle and throne are typically together. And you can see how words start to move a little bit. And again, they're in such a huge space. It's actually not a huge problem. But again, the words are moving closer a little bit at a time. A lot of mathematics involved here. This particularly why it's a very compute intensive process to do training for generative AI. But at the end, what we have is a new relocation for these vectors. Man and woman are very close together, as you can see. King and queen are very close together, but also the distance between man and woman is the same as the difference between king and queen because in that training process, we've kind of moved things toward each other as part of the training and the math. So, what you end at at the end is something called a text embedding. This is not a picture of that. This is just a basic implementation of what a vector would look like, where it has so many different components. And again, you're making small movements for each word, depending on how one word appears near another word in the text. So having done that, I'd like to talk about semantic and vector search. We're all familiar with text search, full text search, which effectively has a word and tries to find another word in the same text. But semantic and vector search really is a new way of doing searching, and it uses the training data that we just talked about to allow you to basically search for a word that is near perhaps another word in that 1,000 or 12,000 dimensional space. I know that's kind of hard to grasp, but I'm going to show you some examples. And I think it should be useful. So, what we do is to do semantic search, we first download a pre trained text embedding. So, somebody's gone through the training process for us. We don't need to do that. We're going to create our own text and we're going to basically download one, or we might create our own. And then we're going to chunk the text into sentences or paragraphs or documents. And then we're going to basically find the text embedding of every word that is in our search. We're going to average those vectors and then we're going to store them in a database. So in that step 3, we're basically going to take the document, not search it yet. We're going to take each word, each sentence, break it up into words, look up the words, average the words into a vector and store that vector in a database along with the chunk. And then to do a search, we're effectively going to take the search. We're going to take the words in the search. We're going to average the words in the search. We're going to create a vector, which is the average of the words in the search. And then we're going to search for the closest neighbor. If you're familiar with nearest neighbor search in Postgres, this is exactly how it works. So I'm going to give you an example. I have a set of text here. The king is a tall man. That's my first sentence. Queen's a beautiful woman. They sit together in the throne room of the castle. I take my first sentence, average 6 vectors. I create an average of that. I store it in a database, second. Same thing for the third. And now I'm going to issue the search. So I've stored 3 vectors and I said, who is the king? That's all I said. And the result I get back is the king is a tall man. And the reason I get that back is because when I take who is a king, I get the pre-trained or vectors for the 4 words. I average them together and I say which sentence is closest to that result. It turns out the king is a tall man is the closest. How does this actually work? I don't have time to really go into detail, but I'll show you just a little real world example. I install PG Vector. I create a document table. I create an embedding table. I load my sentences into these tables. I then run a Python tool, which will look up the OpenAI embeddings for my text. And I basically store those embeddings in the database. And as you can see here, the king is a tall man has an embedding in red. The queen is a beautiful woman, the same thing. And they're all basically stored in the database. Now, to do a search, I basically take the text somebody gives me. I again look up the OpenAI embeddings for those words. I average them, and then you may recognize the nearest neighbor operator here, the less than dash greater than, and I effectively do a search. What's the closest one? And I get the answer. So, for example, who is the king? The closest example is the king is a tall man. Who is tall? Again, the sentence is the king is a tall man. That's pretty straightforward, even for a full text search. But if I ask who is short, I get the king's a tall man, which might surprise you, but short and tall are related. So it thinks that those are the best matches. Who is pretty? The queen is a beautiful woman. It knows that because it's using the OpenAI trained embeddings, it knows that pretty and beautiful are related to each other. Who is in the palace? Again, it knows palace is typically in a castle. So it gives me that sentence. And find where is the chair? It knows that that sit is related to chair, and probably also that throne is related to chair. So it gives me that answer. That's all I wanted to talk about in terms of semantic search. I'm going to talk real briefly about how generative AI works. Again, I recommend you go to my website if you want to watch a video of me giving this talk in a larger format. So there's something called transformers. Transformers effectively create these blocks, which can use a pre-trained algorithm to create new text. Of course, GPUs are very useful for this. So they create something called attention blocks, which I'm not going to cover, but effectively what happens is the way the generative AI works, we have a text like, what is the capital of France? And effectively we look up the vectors for that. And then we run through a process. I'm sorry, I'm going to have to go so quickly. We run through a process where we adjust the vectors for each of the words based on other words in the question. So, for example, capital in France, those get moved closer together. And as we run through these attention blocks, you can see there's a lot of computation going on. We're slowly moving the vectors closer to each other. And then finally, at the end, we get the last vector represents the first result word that we should return to the user. Then we run the process again. We get the second word and so forth, and effectively becomes a machine that generates text. It sounds crazy, but it actually works. So generative AI, let me give you an example of this. For example, what is the capital of France? It knows that the capital of France is Paris because capital and France are close. It moves France close to capital. And once you do that, the resulting vector is actually very close to the Paris vector. Very similar to how king and queen moved around. Capital of France is, it knows what that is. I'm showing you here some adjustments. There is another Paris in Texas. So if you say Columbus is in Ohio, where is Paris? It doesn't, it does mention Texas there. If I say I live in Texas, where's Paris? It actually talks about Paris, Texas, because the word Texas moved the Paris word closer to Texas and farther away from France. It's kind of interesting. Let's talk about how databases can be used here. There's a very common, popular retrieval-augmented generation capability for AI, which uses databases. So I can actually say where is Paris, and what happens is that we can create a JSON document which effectively looks exactly like this, and you pass this to the AI system, perhaps with some other information. That's what RAG typically does; it adds information, and we get some results. So if in RAG, what you do is you have some pre-training information that precedes the query the user types. And typically this information can come from a database. That's why RAG is used. Retrieval augmented generation means we're augmenting our retrieval with some database information. So here I'm retrieving it in red here. Here's a better example. I actually can augment my information with some JSON data that I retrieved from an order entry application. And now I can ask questions like, when were the orders made? And the output is actually using that JSON information to give me information related to those invoices. What's the earliest invoice? It knows that. It can read the JSON. What's the total of all invoices? It can do calculations for me. Kind of crazy. Um, what is the average invoice amount? Again, it's using that data I retrieved from the database, and it's actually giving me a average of those invoices. Um, I can even ask for payment information. I say today is April 15th. What's with 30-day payment inspection with which invoices are overdue? And she walks through this. Incredible how that works. Um, uh, you can even ask, what is the total invoices that are not pencils? And it can do that for me. Again, it's reading the JSON document that I prefixed to the query. And you can imagine how an application program would use this as well. Today, what is the next expected order date? And it actually looks at the days between orders trying to predict. Okay. You can even ask it to generate an SQL query for you. Here's an example where I actually do the RAG call, but I specifically pull the the JSON document from Postgres and then append it to the query. Okay. So this is the talk I wanted to kind of finish with, and I think is most valuable for you, and that is how do databases make sense for for an AI workload. First off, obviously you can do generative AI in a whole bunch of different ways, cloud, self-managed, and so forth. But this slide I think is really helpful. On the right and left hand side, it talks to the various AI features. The middle it talks about details, but at the right, it explains if this is good for AI or good for databases or not. So semantic and vector search, I already showed how that can be done very easily with AI. Text embedding, vector training, probably not good with a database. There's just too much computation. Database strength really doesn't benefit there. Doing transformers, probably not a good place for a database. Retrieval-Augmented Generation, I've already showed you how that can be used really well. Language queries on retrieved data, I think there's a huge potential here of allowing non-SQL language people to query a database and get a reasonable answer. Data analysis and regressions, I think it's very good. And again, even generating SQL queries, I think on the fly is something that's going to be interesting. I have a URL here at the bottom about that. There are a lot of Postgres AI solutions. I've already talked about PG Vector. Tembo has one. EDB has one. Timescale has one. PostgreSML has one. All the cloud vendors seem to have them. There's something called Lantern Cloud. There's WorkKit, PopSQL, a bunch of different ones. And again, DB Tune for server tuning. So this is in its infancy. I expect a lot more AI solutions to come along. Now, in conclusion, I just want to give you sort of a sense of where the landscape is for AI. Again, AI has been around for, well, back in, I don't know, hundreds of years where they were thinking about what AI, what a computer, what a machine would look like, how do machines change man's relationship to the world. That's the pre-computer understanding of AI. We had the Turing test in the 50s, expert systems in the 80s. AI winter was really a sort of a down area for AI. There wasn't a whole lot of thing going on. 2010s were robotics, but really surprisingly 2013, this is really where it took off, at least academically, with something called Word to Vec by Google. And then the concept of attention blocks in 2017 really laid at least the academic groundwork for what happened in 2022 with ChatGPT and Dolly. And again, we all know what has happened since then. How did Google miss the boat? They basically were so focused on their core business, they didn't understand that generating new content and bringing content from multiple websites together to sort of amalgamate and aggregate and summarize information was actually going to be useful to users. Again, they have Gemini, they're trying to catch up. But again, this is one of the reasons I think they weren't the first in this industry, even though they had done a lot of research before them. And I'm going to just close with these two quotes. And again, you have to think about what they mean. But what this gentleman is basically saying that if you told me it is in 2013, if you told me a year ago we'd be able to do all these things with AI, I would have told you it wouldn't happen probably in my lifetime. And now, within 1 year later, it has happened. And he's basically shocked. And I totally understand that. But the second quote is also important. And this is a cautionary tale about what we expect from AI, basically saying that we used to think the idea that people could express themselves or manipulate language was smart, but that's not true. And I think I've shown you this already. You can manipulate language and not be smart. And that's basically what these large language models are demonstrating, because that's exactly what I've shown you when I showed you the transformers, how basically it's using vectors to generate data. It doesn't understand what it's saying, it merely is able to generate it. So I hope this has been helpful. Again, my main focus was to explain what generative AI is, what it does, and then try and merge that with the database needs to try and explain, okay, here's what it is, here's where databases can help, and here's where databases maybe don't make sense. And hopefully that will help you to have a better understanding of where you can take AI with your current database needs and requirements. I think this opens a whole new chapter for what databases are going to be possible for, and it's going to be a very exciting time going forward. Thank you for listening to me today.